Security is important in the digital age as we often deal with confidential information that should be accessed or manipulated by unauthorized or malicious parties. The main method we use to protect our information and devices is through the use of encryption, the process of masking data so it cannot easily be read without proper authorization. Encryption algorithms are what protect our messages, emails, accounts, devices, and other personal information. And most modern encryption algorithms are secure enough that brute forcing through them would take an extremely long time. For example, an RSA 2048-bit integer public key, with a private key being its prime factors, is expected to take much longer than the estimated age of the universe to break down to its prime factors using classical computers. However, in spite of the complexity of these encryption methods, it's only really resistant to attacks by classical computers, as there exists an emerging technology that might render our widely used encryption methods like RSA and AES vulnerable, and that is quantum computers.
A quantum computer is a computer that uses principles in quantum theory to allow it to speed up computations. It uses qubits, which act similarly to bits but have quantum properties of superposition and entanglement.
While a classical bit can only be 0 or 1, quantum superposition allows a qubit to exhibit itself as a combination of 0 and 1 simultaneously. Quantum entanglement, on the other hand, creates a link between the qubits which allows the state of a qubit to be dependent on another qubit, regardless of their distance. So when a state of a set of qubits are changed, a qubit can also be changed by it without us needing to check it.
These quantum properties allow quantum computers to perform multiple calculations at once, dramatically reducing the time needed to solve certain complex mathematical problems, including those being used in modern encryption.
With modern advancements in quantum computing like the Google Willow, Microsoft Marijuana 1, and the IBM Condor, the reality that current encryption algorithms becoming obsolete is coming sooner than we think. This has led to the development of quantum-resistant cryptography, algorithms that are resistant to both classical and quantum computers. The goal is to use mathematical problems that are not only difficult for classical computers but also hard for quantum computers to solve. Eventually, we will need to migrate to these new quantum-resistant cryptographic algorithms, just like how we had to update our time systems during Y2K. Preparing for a quantum future is vital if we want to keep both our information and communications private and secure.
As the future is shaped by quantum breakthroughs, the steps we take today will determine how secure our digital world remains tomorrow. The question isn't if we need to adapt, but when. And that time is now.